We are going to work with trigonometric identity for analytic trigonometry. So here you see formulas that we are going to use for our 6 problems I'm going to solve in this video. Therefore, I would highly recommend, before you start watching solving these problems, I want you to write down these formulas somewhere on a piece of paper, and with numbers. I'm going to use these numbers in solution, so you would know. Plus, I put here the algebraic formula that I'm going to apply. Okay? All right. So, let's start. First one. Oops. Cotangent theta over secant theta. What did I do? Okay. Is equal. Applying identity. Cotangent meaning that's a formula too. Let me use this one. Okay. So that's mean cosine theta over sine theta. And cosecant, I'm going to apply formula 3. Which is going to be 1 over sine theta. Okay, from here, cosine theta over sine theta divide by 1 over sine theta. Yes, this is going to be equal cosine theta. Whoever doesn't remember division of fractions, please open division of basic fractions in my video. It's not an intermediate math the playlist, it's on basic math playlist. So cosine theta times sine theta, and at the bottom we get sine theta times 1. Practically I'm taking this sine theta multiplied by this 1 and cosine multiplied by this sine. Okay, and this is going to be canceling this with this, and we are getting cosine theta. So this is the final answer. Moving to next question. Simplify tangent theta times cosecant theta. All right. Tangent, I am using first formula, and cosecant I'm going to use third formula. So sine theta over cosine theta times 1 over sine theta. Since it's multiplication, we are doing straight multiplication, numerator with numerator, denominator with denominator. And here I can cancel sine theta with the sine theta, and the answer I will get 1 over cosine theta. And 1 over cosine theta is formula number 4, which is equal secant theta. Number 3. Cosine theta over 1 minus sine theta times 1 plus sine theta over 1 minus it's 1 plus sine theta. Don't be surprised that you see on the top also 1 plus sine theta and at the bottom also sine plus sine theta. So numerator and denominator have the same, that's fine. So let's multiply, see what we are going to get here. So first cosine theta times 1 plus sine theta and 1 minus sine theta times 1 plus sine theta. Okay, well, let's multiply, see what we get. Equal cosine theta plus cosine theta sine theta over, and here we have a plus b times a minus b. Look here. So it's going to be, let me take this off not to make messy. So it's going to be 1 squared, which will be 1, will be 1, and minus, it's going to be sine squared, that will be my b squared, sine squared theta, because sine times sine, it's going to be sine squared, and under no circumstances it's not going to be sine theta squared. Let me show you here. Sine theta times sine theta, it's going to be equal sine square theta, okay? And it cannot be equal, you cannot here write down sine theta squared. It's absolutely wrong, okay? Sine times sine, tangent times tangent will be tangent squared. Cosine theta times cosine theta will be cosine squared, but not theta. Theta squared is usually given, okay? All right, so moving on. What we are getting here, 1 minus sine squared theta. Okay, so 1 minus sine squared theta from formula 5, this is going to be equal cosine square theta, right? And this is a formula 5. So we are getting well, since I have here cosine squared, I guess I didn't need to take it out on the top because I can cancel it. All right, let me fix it. I don't need to take this out on the top. I'll just leave it the way it is. Okay, because I'm going to cancel this cosine. So we had 1 plus sine theta. I leave the way we have here in numerator. See that? And the reason I reversed, because I can cancel it. On the top I have cosine theta, at the bottom here I have cosine square theta. So I will cancel it. Let me show you. So this is going to be equal cosine theta times 1 plus sine theta, and this all divided by cosine squared theta. So that's why I put back in original format of cosine theta. I can cancel with this square, right? I don't cancel cosine theta, only square, because see here, degree 1, and I'm getting sine square theta. So when I take off cosine theta, at the bottom I will have cosine theta, which means I will have 1 plus sine Solving problem number 4, that is cosine theta plus sine theta over sine theta plus sine theta minus cosine theta over cosine theta. Okay. So first thing, what do we have to do? It's in addition, bring to common denominator. So here we have sine theta, here we have cosine theta. So denominator will be sine theta times cosine theta, right? Let's bring to common denominator, sine theta, cosine theta. So here we will have cosine theta plus sine theta, and that is at the bottom we will have sine theta, so I have to multiply by cosine theta, right? Because cosine theta is missing. Let me write down here common denominator. It's going to be sine theta and cosine theta. So we multiply by cosine theta denominator, because sine we are missing cosine. On the top also we multiply cosine theta. It really looks ugly. Let me, okay, cosine theta here and cosine theta here. So plus, in this fraction we have cosine theta, so this fraction we need to multiply by sine theta to get both of them. Okay, here we get sine theta minus cosine theta times sine theta. Okay, so let's solve it. If common denominator is the same, all I can do, just add numerators, right? So in denominator I will have sine theta, cosine theta. In numerator I'm going to multiply. So cosine theta times cosine theta will be cosine square theta, plus second one will be sine theta times cosine theta. Okay, let me clean this not to make a mess, so we keep it clean and readable. All right, next we are doing plus. Now next one, sine theta times sine theta will be sine square theta, and then negative cosine times sine, we will get minus cosine theta times sine theta. Okay, we got a long polynomial. So what we can do here, let me see. What do we have here interesting? This is what we have interesting. We have cosine square theta and we have sine square theta. And that is going to give me 1. Here is this formula. Sine square theta plus cosine square theta equal 1. So let's apply that. Number 5 formula. So that's going to be 1. And then what else do we have here? Sine theta, cosine theta, and negative cosine theta, sine theta. It's cancelling. So you realize that sine, cosine, or cosine, sine, it's the same thing because it's a multiplication between them, right? Just like 3 times 2 or 2 times 3. Therefore, with clean conscience, we are cancelling it. and the result is going to be, on the top, in numerator we have 1, in denominator we have sine theta cosine theta. Question number 5. I'm going to solve 6 problems here. Okay, here we need to verify the following identity. Verify, which means we have to show that cosecant x minus cosecant x times cosine square x is equal sine x. We need to prove or verify that the left side of equation equal to the right side, that this is a true equation. Alright, so first thing what I'm going to do, I have a common factor cosecant, right? Look here, cosecant, common factor. So I'm going to take this out. And I will have here left 1 minus cosine squared x. Yes? Now, 1 minus cosine squared x, I am applying this formula 5. If sine squared plus cosine squared equal 1, then for the 1 minus cosine squared will be equal sine squared. So let me write down, I'm going to apply here formula 5 for this piece. This is formula 5. And we're going to have cosecant x times sine square x, because 1 minus cosine square x, we are going to get sine square x. Yes? Alright. Now, what's the formula for cosecant, identity of cosecant? That is our formula 3. Cosecant equal 1 over sine. Let me write down. I'm applying here 3. This is going to be equal 1 over sine x times sine square x. Well, because it's multiplication, it's the same thing if I represent here denominator 1, right? Which means I can do sine will be gone with this square. And the answer we will get is going to be sine x. And that's what we needed to verify, which means it's indeed equal sine x. And the last problem, number 6. Also, we need to establish the identity. Show that one over one minus sine theta plus 1 over 1 plus sine theta, and that is we have to prove or verify whether it's equal to secant square theta. Okay? Alright, let's start working. So, since it's addition, right? So what do we have? 1 minus sine theta, 1 plus sine theta. We are going to apply this algebraic formula, a plus b times a minus b equal a squared minus b squared, right? Moving here, we have also a minus b, a plus b. So common denominator is going to be 1 minus sine theta times 1 plus sine theta, which is 1 minus sine squared theta. Right now I'm not going to write down like that because I need to use it, adjust this denominator. Let's see, 1 over 1 minus sine theta. So what am I missing here? I'm missing 1 plus sine theta, right? So multiplying by 1 plus sine theta, and same thing I'm doing here, 1 plus sine theta. Next, plus 1 plus sine theta. Now this time I need 1 minus sine theta, right? So it's going to be 1 minus sine theta to bring to the same common denominator. And on the top we have 1. So I have to multiply again. Let me put this one blue color because it's original 1. And it's going to be 1 minus sine theta. Okay, so what do we get here? We are getting the following. Now I can write down 1 plus 1 plus the sine theta times 1 minus sine theta. It's going to be equal 1 minus sine minus sine squared theta. Why? Because this is equal, this formula equal a minus ba plus b equal 1 minus a squared minus b squared. So 1 minus sine square theta and denominator are the same. I can combine, and in numerator I'm getting 1 plus sine theta plus 1 minus sine theta. Sine theta I'm cancelling with minus sine theta, right? And what do we get? 1 plus 1, it's going to be 2, 1 minus. Now this one, 1 minus sine theta, we are using formula 5 because the sine square plus cosine square equal 1. And so from here, 1 minus sine square, it's going to be cosine squared theta. So we are going to get cosine squared theta. All right, so we know one thing, that formula 4, 1 over cosine theta equals secant, right? 1 over cosine theta equals secant. We have 1 over cosine squared theta. Let me rewrite this. This is going to be 2 times, here I put cosine theta, and then times, let me write down even better way, even more understanding way. Okay. So I'm taking these 2 separate times, and then I can write down 1 over cosine theta times 1 over cosine theta, like that. And we know 1 over cosine theta, that's formula number 4, it's a secant. Okay, number 4. And we are getting 2 times secant times secant, right? Secant theta times secant theta. Yes? So what do we get? 2 times secant will be secant squared theta. And that's exactly what we needed to verify, which indeed 1 over 1 minus sine theta plus 1 over plus sine theta is going to be equal to secant squared theta. 1 over 1 minus sine theta plus 1 over plus sine theta is going to be equal to secant squared theta. 1 over 1 minus sine theta plus 1 over plus sine theta is going to be equal to secant squared theta. 1 over 1 minus sine theta plus 1 over plus sine theta is going to be equal to secant squared theta. Okay, well, there will be continuation. I'm going to solve some more of trigonometric identity. The more you solve, the more you practice, the better you will have feeling how to solve it when you see the expression of trigonometric function that you need to simplify. Okie dokie, see you in next video.